And here we are again with part 6 of chapter 14. Yes, it's a long chapter. It's got a lot of really, really important ideas. So here we go. We're going to continue. That's why I like to keep it Z0. So it's how many standard deviations this sample mean that I took is away from in the null hypothesis distribution, the mean of the null hypothesis distribution. So how many standard deviations my sample is in this null hypothesis distribution. So let's look at the sweetening cola. Now, we got the mean from that sample of 10 tasters to be 1.02, and in the null hypothesis distribution, the mean was 0. We divide by standard deviation, but remember, we're in a sampling distribution where the standard deviation of our sampling distribution is the standard error, which is sigma divided by the square root of n. So that's why you see sigma divided by the square root of n there. And so when I calculate that, look at that, 3.23 standard deviations from the mean. Should that have happened? If I even pick one cola taster that, is a professional, should his answer be that far out in the null hypothesis distribution? No. Imagine a sample of size 10 to have that average to be that far out is quite unusual. And that is really a very good indication that my null hypothesis is probably not true. Being that many standard deviations, my sample mean being that many standard deviations from the assumed null hypothesis distribution. So how can we quantify this? How can we make it in such a way that it's very objective and that we can quantify this statement? So I can say, 3.23 is way far away, standard deviations from the mean, in which we can quantify this. It's the best way to put that. So let's look. How can we do that? Well, we can get what's called a p-value. Now, the p-value is the probability of obtaining a sample mean that is as extreme or more extreme than the one you just observed. So I took this sample. It's 3 point however many standard deviations from the mean in my null hypothesis distribution. What's the probability that I would take another sample of size 10 and get a mean even further out? That's what your p-value gives you. So the probability is calculated assuming that the null hypothesis is true. When we use the p-value to quantify how unlikely the observed sample mean is, it becomes the basis for us to reject or not to reject whatever decision. What sample means are as extreme or more extreme than the observed depends on the alternative hypothesis. So the formulas for calculating the p-value depend upon that alternative hypothesis. So as I told you, that alternative hypothesis drives your hypothesis test. Now the p-value is a statement about the probability the sample mean takes on specific values. It's not a statement about the probability that the population mean has a certain value. And it is not a statement about the probability that the null hypothesis is true. Again, it's a statement about the probability the sample mean takes on a specific value, that the sample mean would take on the particular value that it did. We'll use that to determine whether it would be likely to reject or not to reject the null hypothesis. So continuing with this p-value approach to a hypothesis test, first you have to state your null and alternative hypothesis and calculate the z-value. Now to calculate the p-value, it's the probability that the test statistic would be this extreme or more extreme if the null hypothesis is true. We compare our p-value to a pre-specified level of significance to determine whether to reject or not reject the null hypothesis. That is, to determine if the result is statistically significant. So we come to this idea of a pre-specified level of significance. What is that? Well, that will be given to you in the problem. And later we'll talk a little bit more about what this level of significance is all about. But first we're going to talk about how do you calculate the p-value for the different types of tests. Remember, we have a right, a left, and a two-tailed test. So let's take a look at the right-tailed test and see how we calculate the p-value. Well, there's our test statistic sitting right there. The p-value for a right-tailed test is the probability that we would get a z greater than that test statistic. So it's the area to the right of our z0. And we've learned how to do that in Chapter 3. So you could either use the complement rule or you could use symmetry of a normal distribution to find that probability. So to calculate the p-value, one way would be the 1 minus the probability that z is less than z naught, or just find the probability that z is less than negative z naught. Either one will give you that p-value. Here's calculating a p-value for a left-tailed test. In other words, we want to find the probability that I would get a test statistic even smaller than the one that I got, that I would get a sample mean even further out into the tail of my null hypothesis distribution. So the way you'd find that is you'd literally just go to your table A, go to the z naught, whatever that is, and see the probability that goes with that. So get that straight from the standard normal table to calculate the p-value on a left-tailed test. Now, a two-tailed test is a little bit different. For a two-tailed test, the way you calculate the p-value is you have a specific test statistic that you get. And whether it's positive or negative, what we want to do with that is we want to see the probability that z would be greater than that z naught or less than the negative of that z naught. So the way we would calculate this is we take twice 1 minus the probability that z is less than the absolute value of z naught to find our p-value. And we'll do some examples of these. It can look a little bit more tricky than it is. Now, once you calculate the p-value, then it is very easy whether you are going to reject or not reject the null hypothesis. For all three of the alternatives, the two left and right tailed, again, the interpretation will be the same. Larger p-values mean that the observed sample is not so unusual, and we would not reject the null hypothesis. But for very small p-values, that means the observed sample is unusual. It's unlikely if the null hypothesis were true. So in those cases, we would reject the null hypothesis. Now, what is too small? What's large, what's small, that type of thing, that's going to be based on a particular alpha, that level of significance I talked about earlier. What we can do is we're going to see that if our p-value is less than a particular value, a particular significance level, that's when we're going to reject the null hypothesis. And that's what we see right here. If our p-value is greater than or equal to this level of significance that will be given to you in the problem, you do not reject the null hypothesis. The p-value, so the p-value is large. The sample mean that you got doesn't seem unusual. Now, we reject the null hypothesis if the p-value is less than alpha. So if in the problem you were given an alpha, a significance level of 0.05, if my p-value was 0.293, since that p-value is greater than alpha for sure, we wouldn't reject it. But if somehow I got the p-value of 0.014, that would be highly unlikely in the null hypothesis distribution, so we would reject H naught. So the summary of the p-value approach, what you're going to do is you're going to set up the hypotheses, the null and alternative hypothesis. Select the level of significance. Now in our class, we'll give you that level. It generally runs between 0.001 and 0.05. The most common values for alpha, or the significance level, is 0.01 and 0.05. And again, those will be given to you in class. Compute the test statistic, Z naught. How many standard deviations my sample mean is in the null hypothesis distribution. Number 4, obtain the p-value. You'll have to use your table A. Or, obviously, Minitab command will give you a p-value, and you'll learn how to do that very soon. Once you get the p-value, you compare your p-value against your alpha. If the p-value is greater than or equal to alpha, do not reject. If the p-value is less than alpha, reject the null hypothesis. Then the very last and very important step is interpretation of the decision in terms of the problem. Your conclusion, stating the conclusion.